You're watching Target 4.6 retest video. In this video, we're going to cover quadratic inequalities. We're going to graph them and then interpret what we see inside that graph. Remember, you should have your white packet with you and out in front of you. I'm actually going to do some of the problems on that white packet. And then you need to have the white packet done fully in order to do any of the retesting. So let's take a look at number 4 and number 5. First, we're going to graph these. Notice this is in standard form. So right away, you should be thinking opposite of b over 2a to find your vertex, and then using your pattern to find the rest of the points. So the opposite of b over 2a looks like this. The opposite of 6 over 2 times negative 1. Negative 6 over negative 2, that gives you 3. And then we'll plug that back in to find y. Notice the negative sign is outside the parentheses here. We're squaring 3 and then multiplying by negative 1. And 3 goes there too. So negative and then 9. So we have negative 9, we have positive 18, and negative 6. So working that out, you get negative 9 plus 18 is 9, minus 6 is 3. So our vertex is 3 and 3. That is right here. Also then the pattern of 1, 3, and 5, you have to multiply that by negative 1. And negative 1, negative 3, negative 5, which is all down. Down 1 over 1, down 3 over 1, and 5 is off the graph. Notice this graph is in like fractions, so that's why it looks bigger. And this is a solid line because it says less than or equal to. Remember, if it was just less than or just equal to, like this, or this, sorry, just less than or just greater than, it would be a dashed. All right, now for shading. For shading, it says y is less than or equal to. That means that for every point that you put out there, y has to be less than it. Less than is down in the y-axis. So pick a point. There it is, down. There's another point, down. Another point, down. Notice all of these points fall inside of the parabola. So therefore, we are going to shade inside. Now, if all those arrows went outside the parabola, we'd shade on the outside. Let's take a look at the next one. Next one's in vertex form. That's easy. It gives us the vertex already. Remember, it's the opposite of that. And the same as the one on the outside. So it's 4 and 2 for a vertex. And this pattern is multiplied by 2. So it's 2, 6, and 10, all up. It's positive. 4, 2 is here. Up 2, right 1. Both sides, because it's symmetric. Up 6. And there you have it. Solid line again. There's our parabola. As far as shading goes, this one says y is greater than. So different this time. Greater than takes us above. So let's look at every point on the graph and draw an arrow up. Notice all of these again fall inside. Okay, so wherever those arrows go, that's the direction which you shade. Now, when might you shade outside? Well, let's look at y is greater than again, but let's say the parabola looked like this. All of the arrows for greater than would go outside and shade everywhere else except inside. So you can take a look at the answers for some of those. You'll see some of them are shaded on the outside too. Now, if you need any more help, go ahead and rewind that, watch it again, or see your teacher before or after school. Let's look at how to write the inequalities. So it asks for them in vertex form. So for an inequality in vertex form, it looks like this, where h and k are your vertex, and a is that number we multiply the pattern by. So we're going to have to look at the pattern to get a. So let's look at our very exact problem here. So vertex, that's easy. It's negative 1 and 5. And then the pattern, notice it goes down 2 before it goes over 1. And then it goes down 6 before it goes over 1. And then my guess is it would go down 10. 2, 6, and 10. These are all down, which means it's negative. So the question is then, how do we get from 1, 3, 5 to 2, 6, and 10? Well, it looks like if we multiply by negative 2, we get there. That ends up being a. So let's start writing our inequality here. Plugging in a, and the opposite of h, so it's plus 1, and the same as k, that's positive 5 then. And now we need to figure out where does it get shaded. So notice if I draw arrows inside the shaded region, that is below every point. Therefore, it's got to be less than. And since it's dashed, it's not equal to, it's just less than. Okay, there's your inequality. Remember, you plug in A, the opposite of H, and then K, and then take a look at the shading, and that'll tell you, is it above or below the graph, less than or greater than. If you need to watch that again, go ahead and watch that again. If not, we're going to move on. If you need help from your teacher, seek them out before or after school. All right, finally, we're going to take a look at whether a point's a solution to an inequality. So possibly the easiest way to do this is to take a look at the graph. So I'm going to call on the Inspire here. We're going to take a look at the graph, and then I'll also show you an algebraic way to figure that out too. All right, so let's plug in greater than or equal to. So we have to delete the equal sign, put greater than or equal to x squared minus 3x minus 10, and we see this. All right, so it's asking you if 1/6 is a solution. Well, 1/6, 1/6, it falls in the shaded region, so it must be a solution. Okay, the second one asks you about -2, -4. Now here's -2, -4. That one's pretty close. My guess is that it's outside, but we should probably prove it with some algebra. So I'm going to guess not a solution, but let's see what happens with the algebra. So remember now every point is an x and a y, so we can plug those in and see if it works. 6 goes where y is, 1 goes where x is, and we'll use PEMDAS to work through it. Exponents first, then multiply, and then we'll add subtract to finish it out. And 6 is greater than -12. It's true, so that means it must be a solution. All right, the same is true for the next problem. Let's see how that one works. -4 goes in for y. -2 goes in for x. After you make that substitution, follow PEMDAS then. -2 squared is +4. We'll multiply. Ooh, -3 times -2 is +6. And then add to finish off the problem. You get 0. -4 is greater than 0. That's false. So that one is not a solution. All right, go ahead and rewind that and watch it again if you need to. Remember, use all your resources here on these problems, but make sure you are able to prove it using algebra. And if you need any more help than the videos, go see your teacher before or after school. Remember that you need to have the whole worksheet done before you are allowed to do any kind of retesting.